Hey guys, and welcome back. We are continuing our unit on energy today by talking about work and power. So without further ado, let's go ahead and jump into it. So what is work? So I'm sure you have at some point in your life told yourself, wow, I really put in some hard work, whether that be at the gym or maybe doing homework. But this idea of work in terms of physical science that we're learning about is the production of force and distance. Okay, so in terms of science, it's the production of force and distance. Work is done when a force acts on an object in the direction the object moves. So if there's no movement, no work is done. Okay, so we're going to keep that in mind as we move forward today. So in order for there to be work, there has to be movement. So for example, when you lift a stack of books, your arms apply a force upward and then the books move upward. Because the force and the distance are in the same direction, your arms have done work on the books. Okay, so this can apply to anything, not just books. So picking up your book bag, picking up your computer, anything that you're lifting throughout the day, your arms and your hands are exerting a force and they are doing work on that object if they're moving in the same direction. So when you carry books while walking, though, you might think that your arms are doing work, right? You feel energy is being exerted, maybe the books are heavy. However, in this case, the force exerted by your arms does no work on the books, okay? So if you are carrying the books forward and you have them at a steady position in your arms, then you're not actually doing work on the books. Okay, so why is that? The force exerted by the arms on the books are upward, but then the books are moving horizontally. So if you just stop and picture yourself carrying books forward, so you have a bundle of books in your arms, you're holding the book stationary and then you are moving forward. So the force from your arms is up, but the force from the books is moving horizontal. So because the forces are not in the same direction, we wouldn't say that the arms are doing work on those books in that instance. So the force that we exert is at right angles to the direction that the books are moving. Sorry, I accidentally paused the video, so I'm not quite sure where that might have cut me off at. And so here is just an example of that. So again, this young lady, she is carrying her books and the force from her arms is up, but then of course the movement is forward. So because these forces are at right angles, her arms are not currently doing work on the books. So when work is done, a transfer of energy always occurs. This is easy to understand when you think about how you feel after carrying a heavy box up a flight of stairs. So you transferred energy from your moving muscles to the box and increased its potential energy by increasing its height. So you have undergone a transformation of energy. And here is the formula for calculating work. So work is equal to force times distance, and then the unit for work is going to be the joule. So when you do these calculations, when you remember no naked numbers in physical science, when you're doing these calculations, you're going to have the joule as the unit, okay? Now, if you take a look at this little triangle here, this triangle will help you with this formula. So the formula, the standard formula is that work is equal to force times distance. But this triangle can help you identify if you're trying to solve for one of these variables, right? So if they're next to each other in this triangle, so like force and distance, if they're next to each other, you multiply. If they're on top of each other, you divide. So what I mean by that is like, so work is equal to force times distance. Force and distance are next to each other in this triangle, okay? If I wanted to solve for force, like let's say a problem is asking you to solve for force, I would cover up the force because that's what I'm solving for, and then the W is over the D. So force would be equal to work divided by distance, okay? And then of course if I wanted to solve for distance, I would cover up the distance, and distance would be equal to work divided by force, okay? So that's just a way to help us visualize this formula. You can of course always just start with work is equal to force times distance and plug in the variables you're given and solve it that way. Okay, so some people prefer that. I myself prefer to do it that way with numbers versus using the little triangle, but I did want to give you guys that option as well since it's here on the screen. So here's an example. So Sarah exerts a force of 40 newtons to pick up her child a distance of 2.8 meters. How much work is done on her child? Okay, so she will be doing work on her kid because she's going to be picking the child up in the same direction as the force that she's exerting with her arms. So we're given the force is 40 newtons, and we're given the distance is 2.8 meters. We're calculating for work. Remember, work is equal to force times distance, so we're going to plug in the force and the distance values to get our answer. So work is going to be equal to 40 newtons times 2.8, and that's going to give us 112 joules, because remember, the unit for work is going to be in joules. Okay. All right, so now let's talk about power, because power and work are very closely related. So power is just the rate of doing work. So how quickly is work being done? Doing work at a faster rate requires more power, and to increase power, you can increase the amount of work done in a given time. So if you want to increase your power, you are just doing more work over a set period of time. So just as power is the rate at which work is done, power is also the rate at which energy is transferred. Because remember, there's an energy transfer when we're talking about work. Think about the energy transferring from your muscles to the object that you are working on. So when energy is transferred, the power involved can be calculated by dividing the energy transferred by the time needed for the transfer to occur. I'm going to show you the formula for this. So power formula is going to be equal to work over time in seconds, okay? So P is equal to W over T, and then the unit is going to be in joules per second. This is also known as a watt. So I don't know if you guys have ever sneaked a peek at your parents' energy bill, but sometimes it'll show you, typically it's in kilowatt hours of energy uses, but a watt is just the unit of power. Okay, so power bills that come is the work that's being used over time. That's what you're getting charged for. Okay, so just like before, this triangle can be used in the same way. So power is equal to work over time. If you needed to solve for work or time, you could just use this little triangle to help you determine what those formulas would be, right? So if you were solving for time, time would be work over power. And if you were solving for work, it would be power times time. Okay, so again, if this triangle confuses you, you can just punch your variables into the standard formula here and do the math through and solve for your variable. Okay, now the other thing is, in these cases, you might have to solve for work. So sometimes it won't give you the work unit, it will have you solve for work, and then you'll have to plug it into the power formula. And I'll show you what I mean in an example here. So here we have a figure skater lifts his partner who weighs 450 newtons, 1.5 meters in 3 seconds. How much power is required? Now, this particular problem does not give us the work, but we know we have to solve the work in order to calculate the power. So we're going to solve for the work first, then we're going to solve for power. Okay, so we are given the force, which is 450 newtons. We're given the distance, which is 1.5 meters. And we're given the time, which is 3 seconds. So now remember our formula. Power is going to be equal to work over time, but we have to solve for work first because we have to have that value so we can divide it by that 3 seconds. So power is work divided by time, and work, remember, is force times distance. So first we're going to calculate work. So 450 newtons is the force, times 1.5 meters is going to give us 675 joules. So remember, the unit for work is joules. So here we have our joules, our work in joules, and now we can plug that into the power formula. So power is work divided by time. We were given our time as 3 seconds. So 675 joules divided by 3 seconds will give us a power of 225 watts. Okay, remember, watts is also joules per second, but we will use the watts as the unit here. Okay, so So that was a quick example. We're going to do some more practice problems today in our classwork assignment. But as always, if you have any questions, just let me know and I will help you through it. And if not, I will catch you guys in our next lesson.